All right, so I'm going to do kind of a quick tutorial on how to use the Energy Skate Park to try and gather some sort of conceptual understanding of the relationships between motion and energy and do all that fun math. So here we have the website, Energy Skate Park Basics. I really wish that you could use a different uh, simulation, but this one will work on your Chromebooks. There is a different simulation that we would have done in class where you can actually collect data. So I asked you to try and do the first two parts of the lab, and the conceptual one you can pretty much, that's the only one you can do with the Energy Skate Parks Basics. The other one, which is the quantitative one, you would need to use a different Energy Skate Park at the PHET website. That's phet.colorado.edu. So if you have access to a different type of computer, like a PC or even an Apple, whatever, just not a Chromebook, because your Chromebook, again, is just your phone. If you have access to that, please try the other one. You can actually get some math and some data from it and do some actual graphical analysis, and you'll gain a better understanding of the equations, because that's the goal of this, is to conceptually understand, hey, why do the equations look like they do? So here we go. Here's how you walk through the intro. So click on intro. You've got a skater. You can pick them up, move them around, drop them if you want to, watch gravity work. You can turn on things like a pie chart and a bar graph and a grid and some speed. And you basically can watch the skater go around. And you're going to see three types of energy here: kinetic, potential, which is really gravitational potential, and thermal. And again, that comes from the friction or heat. There is no thermal energy in this basic scenario, but if you look down here, I can click on friction and you can see what's going to happen to thermal over time with friction. You can also change the mass of your skater, so you can see how that's going to affect things. So in this simulation, basically all I'm trying to get you to do is I'm trying to look at, see, hey, how does height affect potential? All right, how does mass affect potential and or kinetic? Things like that. Just what do you think are going to be the factors playing around with this? Here you can look at their speeds and how it's changing, and you can track the energies and all that stuff. So I kind of just wanted to ask you, what do you think affects these various factors of energy? Like I said, you can also click on the friction one here, and here you can actually mess with the amount of friction that's there. I would again recommend clicking on everything so you can try and get as much information going as possible. And now we do have friction, and you can see what happens to the motion of the skater over time and things like that. So this is more of a real life scenario. If you go down a hill, you're not going to go forever, whereas the intro is not like a real life scenario because, well, you just don't go around forever. So go through those, do the best you can with the two worksheets. I don't expect you to necessarily get everything. That's why I'm having the video discussion. But there is a other one. If you've got some free time and nothing to do on your hands, you can actually build your own skate park. So you can make your skater do whatever you want and just keep adding different sections to it and craziness, whatever makes you happy. And you can have them lock to the track, or gravity can rip them off the track. You can turn friction on or off and just kind of have some fun with it. This lets you erase things. All right, so that's just kind of the basics on how it's going to work. Like I said, do the best with what you got, and I will do that debriefing with you another time. So that's about it.